I'm Anil Kumar sharing with you solution of some test paper questions on application of vectors. Now this particular question you can copy the question and then look into my solution for suggestions. I'll show you a different way of solving this question which I hope is much simpler. Here is the question. A river is 2 kilometers wide. Dave heads downstream at an angle of 35 degrees to the current, which is flowing at 6 kilometers per hour. His motorboat has speed of 20 kilometers per hour. How far downstream does Dave travel in 30 minutes, that is half an hour? What is the length of time required to cross the river? So that is the question before us. First step always is to sketch the diagram, right? So let's say that is the river for us, right, which is 2 kilometers wide. So here's the river which is 2 kilometers wide. So this distance is 2 kilometers. Now what we are given here is that Dave heads downstream at an angle of 35 degrees to the current. So we are assuming current going downwards like this, right? So current is coming downwards in this direction. So it is 35 degrees to the current. So let us say kind of like this. Let us say like this. So this is 35 degrees with the current. So we'll call this angle as 35 degrees. It is also given that the motorboat speed is 20 kilometers per hour, and this speed for the motorboat is 20 kilometers per hour. On the other hand, the stream is flowing at the rate of 6 kilometers per hour. So this stream is going at the rate of 6 kilometers per hour. It is going downwards. Now the question is, how far downstream does Dave travel in 30 minutes? Now whenever you have this kind of a situation, it is recommended that you split the force into its horizontal and vertical components. That helps. So what we have here is speed this time. So we can say velocity is given to us as 20 kilometers per hour. Now its horizontal component will be what? Horizontal component will be, think like this. This is your horizontal component. Now, or if you make a triangle here, that becomes your horizontal component, which is opposite of 35 degrees. So it's sine of that, right? So it is sine of 20. So it is 20 sine of 35 degrees. You get the point, right? So that is your horizontal component of the velocity, which will actually move the boat from this end to the other end horizontally. Vertical component, let's say V, which is downwards in this particular case, will be the cosine of 20, right? So it will be 20 cos of 35 degrees, correct? So that becomes the vertical component. So what we did here was this particular velocity we have split into two components, so which is horizontal and vertical. Now when you combine them together, then you have this velocity, right? So that is how we have done. We are calling this as the horizontal component and this as the vertical, which is downwards. Now you also see that as far as the river goes, in that case, or the stream goes, so as far as stream is concerned, it has only the vertical component, and which is 6 kilometers per hour. Now let us try to understand the question. How far downstream does the Dave travel in 30 minutes? That means half an hour, right? So that is half an hour. Is it okay? 30 minutes. So distance is speed into time. We know distance is equals to speed into time. So distance is speed times time, right? So that is what distance is. So in our case, we need to find the what this downward distance. So we say distance downwards, let's say downwards, right? The components which are acting downwards are VH, right? So I mean V vertical, this V vertical, and the time is half an hour. So we'll multiply this by half plus the stream, which is 6 kilometers per hour. So let me write this as V of stream, right? So V of stream times half an hour. You get the idea. Now V vertical component is 20 cosine of 35 degrees. So we'll write this as 20 cos of 35 degrees, right? Half of this, so divided by 2, plus 6 divided by 2. So that becomes the distance traveled vertically downwards, right? Now we can calculate this answer. So we'll do 20 cos of 35 degrees, so say equals to, divide by 2 equals to, plus 6 divided by 2 is 3. So we'll just add 3. 11.19 is what we get. So we get 11.19 and the units will be kilometers. You get the idea. So that is how very easily you can find how far downstream does Dave travels in 30 minutes. So we can say 11.2 kilometers approximately. Is it okay? So that is the first answer. Now the next question is, what is the length of time required to cross the river? Now to cross the river, Dave has to travel 20 kilometers and the velocity which helps to cross the river is the horizontal component, correct? So time should be equals to distance, which is 2 kilometers, divided by the horizontal component, which is 20 sine of 35 degrees. You understand? That is kilometers per hour, right? Kilometers per hour. So we get the time in hours, right? That is what it is. So let's calculate this also. So we have 2 divided by, within brackets, 20 sine 35, bracket close, equal to. So we get 0.174. Let me write it in different thing, which is 0.174 hours. So you could multiply this by 60 to get minutes, right? Times 60 equals to 10.46. So approximately 10.46 minutes, right? So you say approximately 10.5 minutes. 10.5 minutes Dave is going to cross the river, right? So we get this answer as 10.5 minutes approximately. I hope this method helps you to clearly understand and answer such questions. Since very clearly we need to find distance traveled vertically and time horizontally. So it is good time to actually write down, it's a very good example, to write down the vectors in their component forms and then solve. So that is a better strategy in this situation to use. I hope it helps. Thank you.